Hi, here we have another question from Iran Mathematical Olympiad round number 1, year 1998. The question is to calculate a function which has a specific type of properties. The function f is from natural number to natural number, and we know that for all x and y elements of n, fxy is equal to fx plus fy minus 1. We also know that f30 is equal to 4. And we know that for a limited number of x, fx is equal to 1. The question is we have to calculate f2. First round of Iranian Mathematical Olympiad is usually consists of multiple choice questions. You get 30 questions for 3 hours. So each question approximately 6 minutes. If you answer correct, you get plus 3 points. If you answer wrong, you get minus 1 point. Therefore, you have to be very careful when you select your answer. Now, maybe I spend 5 to 10 minutes, try to solve this exercise, and then come back and see the solution. These are the options. F2 can be 1, 2, 3, 4, 5. Alright, let's look at the solution. This is our function properties and the values, we know it at f30. Okay, so we have fxy is equal to fx plus fy minus 1. Usually with questions related to obtaining a function or a polynomial, we need to put different values into the properties that is given and try to extract new information. And based on those new information, maybe we can guess what the general formula for the function is. For example, we have xy is equal to fx plus fy minus 1. So we can replace y with 1. And let's see what we obtain. In this case, fx will be equal to fx plus f1 minus 1. Obviously, fx with fx disappears, so f1 will be 1. So we obtain some new information. If instead of x we put p and instead of y we put p, we get some additional information. We know that fp2 is equal to fp plus fp minus 1. Alright? Let's, instead of x, I put p2 and instead of y, I put p. In this case, I can calculate fp3. So fp3 would be fp2 plus fp minus 1. I can continue this procedure. fp4 would be fp3 plus fp minus 1. And if we do it until fp power alpha, it becomes equal to fp power alpha minus 1 plus fp minus 1. And if we add all of these equations together, something interesting happens. Because here fp2 with fp2 disappears, fp3 with fp3 disappears, and so on. Eventually, from the left side, we only have fp power alpha. That one is the only remaining component. From the right side equation, we have alpha minus 1 equations because we start from 2 and we ended up at alpha, so it's alpha minus 1. So we have alpha minus 1 fp, and there is one more, so we have totally alpha fp. And then we have alpha minus 1 of minus 1, so it would be minus alpha minus 1. We can rearrange this and write it like this. fp power alpha is equal to alpha times fp minus 1 plus 1. Now this is important because if we select any number p that is not equal to 1, and if we put it here and assume that fp is equal to 1, for any other number than 1, if fp is equal to 1, what happens is that this term becomes 0, so fp power alpha becomes 1. In that case, it means that we have infinite number of x that fx is equal to 1. And that is contradiction because the problem says that only for a limited number of x we know that fx is equal to 1. Therefore, we can conclude that for any p larger than 1, fp cannot be equal to 1. Very important information, and now we use this one to obtain f2. Another information that is given to us is f30 equal to 4. So we can actually write f30. We can write 30 is equal to 15 times 2. So x we put it 15, y we put it 2. So f30 would be f15 plus f2 minus 1. For f15, again, we put x5, y3. So f30 will be f3 plus f5 minus 1. So this is f15. And plus f2 minus 1. So f30 is given is 4. And these 2 minus 1 goes to the other side. Therefore, we conclude that f2 plus f3 plus f5 is equal to 6. But we know that f of any number cannot be equal to 1 if number is larger than 1. Therefore, fp has to be larger or equal than 2. Okay, so if we know that f2 plus f3 plus f5 is equal to 6 and all of them are equal or larger than 2, it means that all of them are equal to 2. That means f2 is equal to f3 is equal to f5 is equal to 2. Therefore, the correct answer will be option B. Alright, let's see what we have learned. In questions that they ask us to calculate a function with specific properties or a polynomial with specific properties, we can always evaluate the function at different input values and try to look for patterns. And then use the obtained patterns along with the other properties that are given, try to identify the function. And sometimes we also need to prove that this function we obtained is a unique answer. Or maybe we have other answers. So throughout the proof, we have to obtain the other answers. Alright, so that's all for this video. I hope that you learned something new. See you next time. Bye.